Hello everyone. Today we are going to prove one of the most famous inequality in mathematics, that is AMGM inequality. We use the idea of function and even a bit of calculus. For AMGM inequality, it stated that if all the AK are non-negative, the sum of AK over n is greater than equals to the product of AK to the power of 1 over n. The equality holds if and only if all the AK are equal. We'll explore three different but related perspectives. So first, let us recall Jensen inequality. For a function y equals to log x, which is concave downwards, we know that any line segment joining 2 points on the curve will be always lies below the curve. So this means that the f of summation ai over n will be greater or equals to the summation f of ai over n. And in this case, fx equals to log x, so this will be log of summation ai over n greater than or equals to the summation log of ai over n. We know that log a plus log b is equals to log ab. The right hand side of the inequality is simply equals to the log of the product of ai over n. And we also know that log an equals to n log a. So divided by n is meaning that multiply with 1 over n. So this is log of the product of ai to the power of 1 over n. Now what we have is log of summation ai over n is greater than or equals to log of product ai to the power of 1 over n. Since the function of log x is increasing, this will mean that the summation ai over n is greater than or equals to the product of ai to the power of 1 over n, and this is the AMGM inequality. Now we shall look at the second method. We are using the idea of linear approximation. So if y is very close to a, so we know that fy is about fa plus f prime a y minus a. Again, in this case, we are using the function fx equals to log x. The function is concave down. Fy is always less than or equals to fa plus f prime a y minus a. To make our discussion easier, I'll let a to be the summation ai over n and g to be the product of ai to the power of 1 over n. We want to show that a is greater than or equals to g. Now again, we let fx to be log x, and therefore f prime x equals to 1 over x. Suppose x in this case equals to a, then f prime x is equals to f prime a equals to 1 over a. Since we know that fy is always less than equals to fa plus f prime a times y minus a, and this means that f of ai less than equals to f of a plus 1 over ai minus a, and therefore log of ai less than equals to log of a plus 1 over ai minus a. We take the summation for both sides. So summation of ai is less than equals to summation of log a plus 1 over a summation ai minus a. Again, using the property of log, summation of log ai equals to log of product of ai. And summation of log a is just equals to n log a. And for this, it will equals to the summation of ai minus na. So we see that summation of ai minus na is actually equals to 0. So we have log of product of ai is less than equals to n log a. So 1 over n log product of ai is less than equals to log A. Log product of AI to the power of 1 over n less than equals to log A. And the left hand side is actually log G less than log A. Again, the function log is increasing. This means that G is less than or equals to A, and this is what we want to prove for AMGM inequality. So this end of the idea of linear approximation. So for number 3, we'll consider the function EX. EX is equals to 1 plus x squared over 2 factorial, x cubed over 3 factorial, and so on and so forth. But if we just compare EX and 1 plus x, you notice that EX is greater than equals to 1 plus x. And this can be proved using the technique in calculus. So for now, we just focus on the inequality EX greater than or equals to 1 plus x. Again, we let A to be the summation AI over n and G to be the product of AI to the power of 1 over n. So replace x by log of AI over A will be greater than equals to 1 plus log AI over A. For the left hand side, it is AI over A. So when we take the sum for both sides, we have summation AI over A greater than equals to n plus summation log AI over A. A equals to summation AI over n. So summation AI over A will equals to n. So n is greater than equals to n plus summation of log equals log of the product. And this actually equals to n plus log of the product of AI over A to the power of n. Since n is greater than equals to n plus log of product of AI over an, this means that log of product of AI over A to the power of n must be less than or equals to 0, which means that product of AI over an must less than or equals to 1. And therefore, product of AI less than or equals to A to the power of n. Therefore, product of AI to the power of 1 over n must less than or equals to A. But the left hand side is actually equals to the geometric mean. So the geometric mean less than equals to the arithmetic mean. These are the 3 different methods to show AMGM inequality. That's all for today's lesson. Hope you enjoyed it. I'll see you again next time. Bye bye.